Science, science in pajamas. All right, you guys. So, welcome back. Today we are going to be talking about how to derive a final displacement equation using constant acceleration. Ugh. Now, if you remember, displacement, sorry about that, is delta x. And we want to find out the final displacement, which would be xf. However, in the equation for acceleration, there is no displacement. So what we're going to do is we're actually going to combine some of the stuff we already know in order to create what's called the final displacement equation, and it's for constant acceleration. All right, so let's talk about things we know already. Well, from our previous lessons, we know that the average velocity is equal to the change in x, or the change in displacement, over change in time. We also know that average velocity is equal to initial velocity plus final velocity divided by 2. So what we're going to start doing is setting these equal to each other, because both of them are equal to the average velocity. So what I can do then is say, if delta x over delta t is equal to average velocity, and vi plus vf over 2 is equal to average velocity, then delta x over delta t must equal vi plus vf over 2. All right, so what I'm going to do now is rearrange this, because I want to get delta x by itself, which what I'm going to have to do is move delta t. So we're going to multiply both sides by it so it cancels out there. And we are left with delta x equals vi plus vf over 2 times delta t. All right. I'm just going to put this in a little bit easier way to look at. 1/2 times vi plus vf times delta t. It's the same thing, we just don't have to worry about the 2 on the bottom. We don't have to worry about that fraction. All right. Well, something we know from a previous, actually I'm going to write this at the top so that I don't forget. I'm going to erase this stuff, and I'm going to move this equation to the top. All right. Now let's go back to our acceleration equation. In a previous video, we had rearranged it to solve for final velocity. So we had taken the acceleration equation, and we can rearrange that, which we've done in a previous video, so I'm not going to do it now. We can rearrange it to be vf equals vi plus a times delta t. Now what I'm going to do with this, I'm going to take this portion and plug it in for vf. So final velocity equals this. So what I'm going to do is then, if final velocity equals this, I can take this and plug it into that. All right? Yeah. Sorry, changing positions. So then we would have delta x equals 1/2 VI plus, this is where I'm plugging that in at, plus VI plus A times delta T, and then don't forget that delta T at the end. All right. Yeah. Now I know this looks scary. I'm just showing you how we get the final displacement equation. That's all I'm doing right now. I'm just showing you how we get the equation. All right, so we can take this and we can simplify it. We're going to go through a whole round of simplifying. And we know we have VI plus VI. So we can take that and combine them. 1/2 2VI plus A times delta T, and then close parentheses, delta T. So all we did was combine the VI plus VI to make 2VI. All right. Now I'm going to distribute the T across. So we're going to take the T and distribute that to each set of terms within that parentheses. Whew. And the U is that table. So we have delta x equals 1/2 2 VI times delta T plus A times delta T squared. So delta T times this delta T would be delta T squared. All right? Shift this up. Yes, I got my notes to help me. This way I know not to make any mistakes in the video. All right. So now what we're going to do is distribute the 2, or the 1/2. So essentially we're going to divide each of these by 2. Now, since we have a 2 here, this will cancel out, and we are left with delta x equals VI delta T plus A delta T squared over 2. But I don't like putting that in a fraction, so once again I'm going to simplify it and put it as VI delta T plus 1/2 A delta T squared. All right. Whew. Check this out. Quite a monster, isn't it? Sorry though, we're not done. Alright. So next, what we are going to do is first I'm going to move my computer out of the way over here, so I can easily push this up a little bit more. Yeah. Alright. Now remember, I told you that we were going to be looking for the final displacement. Well, I don't see XF anywhere on here, but I do have change in X. And as you remember, hopefully you remember, delta X equals XF minus XI. So if we know this, if delta X equals this, I can take this and plug it in for delta X. So we have xf minus xi equals vi delta t plus 1/2 a delta t squared. Alrighty. Whew. Don't worry, I promise, we are almost done. Alright, well now I gotta just simply get xf by itself. So, to do that, I'm going to add the initial x to both sides. So it'll cancel out on that side. And we are left with our final displacement equation. xf equals xi plus vi delta t plus 1/2 times a times delta t squared. And that, ladies and gentlemen, is how we got the final displacement equation. Now, the reason why I like to show how these equations are derived is because a lot of times when kids are just presented with just this equation, they have no clue where it came from. But we already talked about what displacement is and what velocity is and how they relate to each other along with time. We already talked about what acceleration is. So now we're just putting those concepts together and showing you how we're able to come up with this equation based on the ideas we already knew. So that's all this is about, showing you how we derived the final displacement equation. So I hope that was helpful. But yeah, all right, you guys. Stay awesome. Stay curious. Most importantly, stay safe and healthy. Ripley says hi too. All right, you guys, take care.